So, what is the explanation, the official explanation as to how the astronauts
The
were?
cosmos has always whispered secrets to those willing to listen, but sometimes those whispers turn into shouts that shake the very foundations of what we believe. Imagine a world where the invisible forces cradling our planet aren't just silent protectors, but dynamic, living systems, capable of rewriting the rules of space travel, shielding astronauts, or even broadcasting humanity's existence to distant stars. In early 2025, NASA unveiled a discovery so profound it forced scientists to rethink everything they thought they knew about Earth's mysterious Van Allen radiation belts. These aren't just bands of energy encircling our world. They're a cosmic puzzle, a natural laboratory, and perhaps a gateway to technologies that could propel us beyond the stars. What they found wasn't just a scientific breakthrough. It was a story of awe, danger, and possibility that demands to be told. Picture this: a solar superstorm, so fierce it paints the skies with auroras as far south as Florida, triggers something no one expected. New radiation belts forming in places they shouldn't, lingering like uninvited guests for months. This is the tale of how Earth's invisible shields are far more than barriers. They're a testament to our planet's restless energy and humanity's unintended influence on the cosmos itself. It all began in May 2024, when the heavens unleashed a spectacle that left the world gasping. A solar superstorm, one of the most powerful in decades, erupted from the sun, sending waves of charged particles hurtling toward Earth. While people on the ground marveled at the shimmering northern lights, NASA's instruments were locked on something far more extraordinary happening above. High in the magnetosphere, where Earth's magnetic field wrestles with the fury of the cosmos, something unprecedented was taking shape. Two entirely new radiation belts materialized in a region scientists had long considered safe, a gap between the inner and outer Van Allen belts, a supposedly empty corridor where satellites glide and astronauts pass. These weren't fleeting sparks of energy. They were persistent, defiant structures that lingered for months, rewriting the map of near-Earth space. The first belt, a swirling dance of electrons, held its ground for 3 months. The second, packed with high-energy protons, baffled scientists by remaining stable for nearly a year. These weren't the familiar belts we've studied for decades. They were something new, something that defied every model we had. NASA's Serbi-Cubat satellite, perfectly positioned to witness this cosmic drama, captured data that left researchers stunned. The slot region, once thought to be a reliable safe zone, was suddenly alive with dangerous radiation that could fry satellite circuits or threaten human explorers. This discovery wasn't just a footnote in a scientific journal. It was a wake-up call. NASA scrambled to revise its orbital safety protocols, realizing that the assumptions underpinning decades of space missions were flawed. If these belts could form without warning and persist for months, every satellite launch, every crewed mission faced new risks. The findings, quietly published in the Journal of Geophysical Research in early 2025, revealed a composition unlike anything seen before, a chaotic mix of electrons and protons coexisting in ways that defied physics as we understood it. This wasn't just a quirk of space weather. It was a revelation that the Van Allen belts were far more dynamic than we ever imagined. They weren't static donuts of radiation, but living, breathing systems, shaped by the sun's fury and, astonishingly, by humanity itself. The implications rippled far beyond the laboratory. What if these belts weren't just hazards but keys to unlocking revolutionary technologies? What if the energy trapped in these invisible rings could power the spacecraft of tomorrow or shield astronauts from the very radiation that threatens them? The discovery cracked open a door to possibilities that felt like science fiction but were grounded in hard data. Here's where the story takes a turn that feels almost too wild to believe. For decades, we've been shaping space without even realizing it. Earth's very low-frequency radio waves, the kind used to communicate with submarines deep beneath the oceans, have been carving out a plasma bubble that stretches thousands of kilometers into the cosmos. These signals, born of human ingenuity, have physically pushed back the inner edge of the Van Allen belts, reshaping the very environment of near-Earth space. Historical data reveals something jaw-dropping. Before we filled the airwaves with our transmissions, the belts reached closer to Earth's surface. Our technology has been terraforming space, not with bulldozers or machines, but with the invisible power of our own voices. Scientists now believe these man-made signals have created a protective cocoon, a barrier that holds back the worst of the radiation. This accidental influence is profound, but what if we could wield it deliberately? NASA is already exploring targeted VLF transmissions as a tool to clear radiation from the belts after solar storms, creating safe passages for spacecraft or shielding satellites from harm. It's a glimpse of a future where we don't just navigate space but sculpt it, bending the cosmos to our will. This isn't the first time we've meddled with the belts. Back in 1958, it targets. The human cost of venturing through the Van Allen radiation belts is a question that has lingered since the Apollo missions, when astronauts passed through these intense regions of trapped particles with surprising ease. The belts, discovered in 1958 by James Van Allen, are not just static hazards but dynamic systems that pulse with the rhythm of the cosmos. In early 2025, NASA's revelations about new temporary belts forming after a massive solar superstorm in May 2024 turned decades of assumptions upside down. These belts, appearing in a supposedly safe gap between the inner and outer belts, weren't fleeting anomalies. They persisted, one for 3 months, another for nearly a year, packed with a strange mix of electrons and protons that defied our understanding. This wasn't just a scientific curiosity. It was a wake-up call that the space we thought we knew could transform in ways that challenge our technology, our safety protocols, and our dreams of deep space exploration. The discovery hinted at possibilities beyond mere survival. Could these belts hold the key to revolutionary propulsion, antimatter harvesting, or even a cosmic beacon announcing our presence to the stars? The story of the Van Allen belts is no longer just about danger. It's about humanity's unintended mark on the cosmos and the untapped potential swirling above us. Let's rewind to May 2024, when the sun unleashed a superstorm so fierce it painted the skies with auroras as far south as Florida. While people on the ground snapped photos of the shimmering lights, NASA's Serbi-Cubat satellite, perfectly positioned in orbit, caught something far more profound. In the supposedly safe gap between Earth's permanent Van Allen belts, 2 new radiation belts emerged, defying every model we had. One, a swirling mass of electrons, lingered for 3 months. The other, dense with high-energy protons, held steady for nearly a year. These weren't just blips. They were persistent, rewriting the rules of near-Earth space. The slot region, long considered a safe corridor for satellites and astronauts, was suddenly alive with dangerous radiation that could fry electronics or endanger human explorers. NASA's findings, published quietly in early 2025, revealed a chaotic mix of particles coexisting in ways we couldn't explain. This wasn't just a quirk of space weather. It was a revelation that the belts are far more dynamic than we ever imagined, shaped not just by the sun, but by humanity itself. The implications hit like a shockwave. NASA scrambled to rethink orbital safety protocols, realizing decades of assumptions about the slot region's safety were wrong. If new belts could form without warning and persist for months, every satellite launch, every crewed mission, faced new risks. But the discovery also opened doors to wild possibilities. What if these belts weren't just obstacles but resources? What if their energy could power the spacecraft of tomorrow, or shield astronauts from harm? The data hinted at technologies that sound like science fiction but are grounded in reality. Propulsion systems, radiation shields, maybe even a way to harvest the cosmos itself. And then there's the stranger truth. We've been shaping these belts for decades without knowing it. Our very low-frequency radio waves, used for submarine communication, have carved out a plasma bubble stretching thousands of kilometers into space, pushing back the inner edge of the belts. Historical data shows the belts once reached closer to Earth's surface before our airwaves filled the skies. We've been terraforming space, not with machines, but with the invisible power of our own signals. This accidental influence is staggering, but what if we could wield it deliberately? NASA is already testing targeted VLF transmissions to clear radiation after solar storms, creating safe corridors for spacecraft or protecting satellites. It's a glimpse of a future where we don't just navigate space, we sculpt it, And the story gets wilder. In 1958, during the Cold War's fevered pitch, the U.S. conducted Project Argus, detonating nuclear weapons in space to create an artificial radiation belt that encircled Earth for weeks. It wasn't an accident. It was deliberate engineering, proving we could reshape the radiation landscape of low Earth orbit. Those experiments showed we could alter space itself, and the physics hasn't changed. Only our tools and ambitions have grown. Today, whispers in defense papers suggest strategic uses, blocking satellite access or creating temporary radiation zones to disable spacecraft. The line between protection and weaponization blurs, but NASA's gaze is fixed on something brighter: antimatter. The PAMELA satellite found antiprotons trapped in the belts, especially in the South Atlantic anomaly, in quantities no one expected. Proposals now float the idea of magnetic scoops to harvest this cosmic fuel, turning the belts into a natural gas station for spacecraft bound for distant planets. The Van Allen belts are no longer just hazards. They're a dynamic system we're already shaping, a reservoir of energy we might one day tap, and a mystery that keeps unfolding. Each revelation pulls us closer to a future where space isn't just a destination, but a canvas we're already painting, whether we mean to or not. The belts are alive, responsive, and brimming with potential, and their story is only just beginning. The Van Allen belts pulse with a restless energy, a cosmic dance of particles that both shields Earth and challenges our ambitions to explore beyond it. In early 2025, NASA's discovery of new, temporary belts forming after a May 2024 solar superstorm revealed a truth we're only beginning to grasp. These aren't just barriers, but dynamic systems we've already begun to shape. The belts, born of Earth's magnetic field clashing with the sun's fury, hold secrets that could redefine space travel, from antimatter fuel to radiation shields. But there's a darker side, a human cost that looms as we push toward the Moon and Mars. The story of these belts is one of wonder, danger, and the delicate balance between harnessing their power and respecting their unpredictability. Picture the astronauts of the Apollo era, hurtling through the Van Allen belts toward the Moon, their spacecraft piercing these invisible rings of radiation. Back then, we thought we understood the risks: brief exposure, manageable doses. But the 2024 findings upended that confidence. The new belts, with their chaotic mix of electrons and protons persisting for months, revealed a space environment far less predictable than we believed. NASA's Artemis program, aiming to return humans to the Moon and beyond, now faces a sobering reality. The radiation landscape is shifting, and prolonged exposure could carry unseen consequences. Recent studies hint at subtle but serious risks, not just burns or acute sickness, but long-term effects on the brain, genes, even sleep cycles. NASA's BIOST missions, orbiting labs studying cells and tissues, are uncovering how these belts might alter the very fabric of life. The data is unsettling. Low-dose radiation, over time, could cloud an astronaut's mind or rewrite their biology in ways we're only starting to understand. As these temporary belts form and linger, the path to deep space grows more treacherous, demanding new ways to protect those who dare to cross it. Yet, even as the belts pose dangers, they whisper of extraordinary possibilities. The discovery of antiprotons, trapped in the South Atlantic anomaly, is a spark of science fiction made real. NASA's funded proposals envision spacecraft skimming the belts with magnetic scoops, harvesting antimatter to fuel journeys to Jupiter or beyond. A microgram of this stuff holds energy millions of times greater than chemical rockets, a cosmic battery orbiting Earth. Imagine probes fueling themselves from these belts, turning our planet's magnetic field into a launch pad for the stars. But it's not just propulsion. The belts could be sculpted, their radiation cleared by targeted radio waves, creating safe corridors for missions. This isn't fantasy. NASA's testing it now, building on decades of accidental influence. Our submarine signals have already pushed the belts outward, carving a plasma shield visible from space. This power to reshape our near-Earth environment hints at a future where we don't just survive the belts, but command them, turning hazards into tools. The story takes a stranger turn, when you consider what these belts might mean beyond Earth. Our radio signals, pulsing into space, create a plasma shell that could be seen across interstellar distances, a beacon announcing humanity's presence. Researchers now wonder, could alien civilizations be broadcasting similar signatures, their magnetic fields shaped by their own technology? The Van Allen belts might not just be Earth's shield, but a cosmic fingerprint, a sign of a technological species. SETI scientists are starting to listen, not just for deliberate signals, but for these accidental markers of advanced life. It's a humbling thought. The belts we've studied for decades might be shouting our existence to the stars, and we're only now realizing it. This interplay of human technology and cosmic forces transforms the belts from a scientific curiosity into a bridge between Earth and the universe. A reminder that our reach extends far beyond our intentions. The belts are more than a challenge. They're a mirror reflecting our audacity and vulnerability. As NASA probes deeper, each discovery reveals a system alive with potential, responsive to both nature and our touch. The 2024 superstorm showed us how little we truly know, how quickly the cosmos can rewrite the rules. Yet, in that uncertainty lies opportunity to protect, to innovate, to explore. The Van Allen belts, once seen as obstacles, are emerging as a natural laboratory, a resource, and perhaps a signal to the stars, urging us to keep pushing, keep questioning, and keep dreaming of what lies beyond.